So this problem, are you going to get one this hard on the quiz?
No.
No, but it's a good problem. I mean, if you tried doing it, you may have. How many of you got stuck on number 9? That should be a lot. How many of you got number 9? Nice. If you got number 9, high five. Okay, so the first thing you always do is you set up a diagram. So what we have here is this person on a journey, driving with a constant speed of 89.5 kilometers per hour. So I'm going to label that as velocity. V is 89.5 kilometers per hour. And this person drives, and then somewhere along the way takes a rest stop. So I'm going to label this point right here as the rest stop. And I'm going to label the time of rest as TR. TR for time of rest. 22 minutes. Now, at this point, you should recognize something. You should be like, uh-oh, we got a problem. Who can tell me what our problem is? Yo. Well, that's not a problem. That's true. At the rest stop right here, during the rest stop, the velocity is 0, but that's not the problem. It has to do with the unit. Look right here. Minutes and hours. Do minutes and hours work together? No. So you got to make the units the same, right? And 22 minutes is not 0.22 hours. 22, there's 60 minutes in an hour. So converting minutes to hours, you go 22 divide by 60. So that comes out as 0.36 repeating hours. 22 minutes is 0.36 hours. So you got to make the units the same. Okay? All right, so after the rest stop, the person continues driving. Drive, and then down to here. And what we're told, let's see, the person's average speed for the whole trip. So now the way you show average is you put a little line above it. So that little line there means average. The person's average speed for the trip is 77.8 kilometers per hour, which makes sense. The average for the trip, the average velocity for the trip is less than the instantaneous velocity while driving because of why? Because of the rest stop, the person takes a break, and that lowers the overall average velocity. Okay, so what we're trying to figure out is the total distance traveled in this trip. So from here all the way to here, we want to figure out, well, let's just call it x, or delta x, displacement. What is the displacement for the total trip? And then B, what's the total time spent traveling, which includes the 22-minute rest stop? So the key to this problem is writing equations that fit the situation. So I'm going to shrink this down a little bit. Can you guys still see that?
Is it just distance, not displacement?
Well, distance and displacement are the same as long as there's no change in direction.
But it doesn't tell you the direction.
Yeah, so notice here they're saying the word distance. So, here, from this point to that point, so yeah, we could call it distance. Distance and displacement are the same as long as there's no change of direction. So this delta x right here is the distance. But I see what you're saying too. No direction was mentioned. If no direction's mentioned, then technically you're not supposed to use the word displacement, right? Anyway, so how do we do this? It has to do with writing an equation for each of these velocities or these speeds. So let's start with this. What can we say about the instantaneous velocity? The velocity while in motion. The velocity while in motion is going to be delta x divided by what? The time of travel. So I'm going to put t sub t. So we have t sub r. What was t sub r? Time of rest. And then t sub t is the time well in motion, well moving. That includes the time for the first part and the second part. Okay? So this equation right here is the equation for the velocity well moving. You take the total distance or displacement and divide by the time while traveling, and that's going to give you this, the 89.5. Okay, now what can we say about this? Well, what's the average velocity going to be? The average velocity is going to be delta x over what?
Delta t.
The total time. The total time from start to finish. What was the total time? Time of travel plus time of rest. It's the total time for the whole thing, right? Now, looking at these two equations, I just want to point something out. We have two equations and two unknowns. What are the two unknowns? We don't know delta x, and we don't know time of travel, right? Delta x and time of travel are the two unknowns. If you have two equations and two unknowns, can you solve it? Yeah. You know, just like in math class, look, remember this in math class? You were like 3x plus 4y equals 7. 2x minus 3y equals 4. Remember doing that? Substituting equations together? That's all this is. That's all this is. So the rest of the problem is just algebra, which I'll work out for you. So let's do this. So what I would do is take this. Let's see, the easiest way to do this is take, let's rewrite this. So this is going to be average velocity, time of travel plus time of rest equals delta x. And then take this equation right here. Delta x is going to be velocity times time of travel. And then take this equation. What do these two equations have in common? They're both set equal to what? Delta x, and the delta x's are the same. Okay, so now what you're going to get, so I'm going to set this equal to this. So now we have v time of travel equals average velocity time of travel plus time of rest. However you guys do your algebra, you know. And then distribute this. And then now we got to isolate time of travel. So now we're going to go v time of travel minus v average time of travel equals average velocity time of rest. So time of travel is going to be equal to, let's see, v average divided by v minus v average. Wait, I left something out here. Hold on. Oh, time of rest. I left out time of rest. Okay, so now we can plug numbers in. Are you guys totally lost?
Yes.
This will not be on the quiz. Time of travel, so v average is 77.8 kilometers per hour. Time of rest is 0.36 repeating hours. And then v instantaneous is 89.5 kilometers per hour. And then this is 77.8 kilometers per hour. So you punch this into your calculator. And you get 2.438 hours. So we come out with time of travel equals 2.438 hours. So the total time, you have to take the time of travel and add it to the time of rest. So the total time of travel, which is the answer to part B, is, so 2.438 plus 0.36, and we get about 2.8 hours. Now, how do we get part A?
Wait, that wasn't part A?
Well, we came out with the time first, which was part B. And that's a good thing to mention. You know, when you're doing physics, sometimes it's easier to do part B before part A. Could we have solved for part A first? Solve for the delta x? You could have, but the way I did the algebra, I came out with time first. All right, so how do we find the total distance? We're going to take this equation down here. Take this equation right here, the delta x. I'm going to bring it up here. So we have delta x equals v times time of travel. And which v is that? The average or the instantaneous? The instantaneous. 89.5 kilometers per hour. And that was for, so the time of travel was 2.438 hours. Just the time while moving. So this gives 218 kilometers. Okay.